Calculate the specific heat capacity of the 300-gram brick, round to two decimal places. So let's start out with what we know. First of all, we know the equilibrium temperature is 80 degrees Celsius. Okay. So let's also start with, what we need to know is how much heat. And we don't know the heat, but we know the heat lost by the water. And the heat lost by the water is equal to mass C change in T. And the mass of the water is 200 grams times 4.18 joules per gram degrees Celsius. And the change in temperature in this case, because it was boiling water, is 100 minus 80. So in reality, that's 20 degrees Celsius. And in a previous problem, we did that, and we found that to be 16,720 joules. So now what we want to do is find the specific heat of water. No, the specific heat of the brick. So I'm going to write another equation, but this time it's for the brick, which equals the mass of the brick times the specific heat of the brick times the change in temperature. Well, it was from the brick was at 25 and went to 85, so the change in temperature is 55 degrees Celsius. That's important because that will go in there. And what we're trying to find is this, and the mass of the brick is 300 grams. If we only knew this, we'd have the answer, but we do know that the specific heat, the heat lost by the water, is a heat gained by the brick, and this is the amount of energy lost by the water. So I'm going to rearrange this equation. Okay, so let me change color here. So I'm going to rearrange this equation for this. Okay, so the specific heat of the brick is going to equal the heat divided by the mass times the change in the temperature there, which is equal to 16,720 joules all over 300 grams times 55 degrees Celsius. And when we're done, we come out to have a number. And the specific heat is equal to 1.01, and see the units are left, grams, degrees Celsius, so the units of specific heat of the brick are joules, gram, degrees Celsius. So that's how we solve that one. The key note was the energy gained by the brick is equivalent to the energy lost by the water. And there is no way to find the energy without knowing that. And you need the energy so you can solve for the specific heat of the brick. Because we have this and we have that. We just needed this, and we got that from another problem. Okay, that will be good.